folks, we are taking up the exercise 3.3. This is the part 1 video. Before starting the exercise, you would have gone through all the formulae that is coming before the exercise. We have to get thorough with the formula. It's on the basis of those formulae that we are going to solve the problems over here. It's a huge exercise with 21 or odd problems. So we'll be taking it conveniently in different parts and getting the problem solved. So this is part 1, and the very first problem, let's see what it says. It says that sine squared pi by 6, sine squared pi by 6 plus cos squared pi by 3 minus tan squared pi by 4. They ask us to show that this is equal to minus half. That's a question. These are the initial group of questions. They approved that kind of questions and they are asking us to prove all this. These are by and large, they are standard angles. So therefore, it is just a matter of substituting and getting the answer. Now, in the previous video, I had given you a ready reckoner as to how we convert the degree measures into radian measures. We have to get used to the radian measures. We are comfortable with degree measures, so also we have to get used to the radian measures, and then only we are able to substitute and get the answers. So, in order to prove this, let's consider first the LHS. Consider the LHS. And what is there in the LHS? Pi by 6, please keep in mind, it's 30 degree. Then pi by 3, it is 60 degree. And pi by 4, it's 45 degree. So all these are known to us. We are just going to substitute and get the answer. So let's substitute. Sine squared 60 for us, we know that sine squared 30, we know that sine 30 is half. So it is going to be half square. First one. Cos 60 we know is half, again it's square, so it's going to be half square. Then minus tan 45 we know is 1, so it's going to be 1 square. Let's solve this. It is going to be half into half. That's how we have half square. So half into half, it's 1 by 4. Then this also half into half, it's 1 by 4 minus 1. Now, because the denominators are same, we can add the numerators. Otherwise, you can have your common sense that quarter plus quarter is half, like that. Whatever way. You use your logic and you get this as half. Otherwise, when you use your normal fractions, 1 plus 1, 2 by 4, which reduces to half. That way also you can get the answer. So, you are getting half minus 1. Now, again, you can use your logic that half minus 1, it's going to be minus half. Otherwise, we use our fractions that here the denominator is 1 into 2 into 2. So therefore it will come to 1 minus 2 by 2, and that is 1 minus 2 is minus 1. So it is minus 1 by 2, and that is our RHS, and that's how we prove this. Hence proved. That's how we prove the first question. So like that, let's move to the second question, and let's see what they ask us in the second question. They are asking us 2 sine squared pi by 6. It is 2 sine squared pi by 6 plus cosec squared 7 pi by 6 into cos squared pi by 3. They say this is equal to 3 by 2. You need to show that this is equal to 3 by 2. Now always these kind of questions, you first look out for standard angles and try to get way out for that. Now pi by 6 it's 30. And pi by 3 it's 60. So this measurement will be easy for us to write and substitute. This is also easy for us to write and substitute. But this cosec 7 pi by 6 is not so direct. We have to work it out and we have to get a particular value for it, and then only we can work with the LHS. So let's see now how to go about doing it. So what we will do is, because we are beginners, let's consider that term alone. Let's consider cosec 7 pi by 6. Now, lots of conversions we did yesterday. So, on the basis of that, let's proceed. I have always told you that when you get an angle like this, the numerator should be as far as possible an even multiple of the denominator plus something. Let's try to get it that way. Now, here, only thing that can work is probably 6 pi plus pi by 6. This seems to work better. Others may become a little more complicated. So maybe this will work better. So then what will happen? This will become cosec. Now 6 pi by 6 plus pi by 6 when we solve it, right? Now this 6 and 6, they can cancel each other and you will get cosec only pi left plus pi getting pi, 2 pi or whatever, our first work is to classify into quadrant. Now this would lie in which quadrant? It is of the type something like pi plus theta. So which quadrant does it lie? Let's logically see it. Which quadrant would it be lying? Pi plus theta is always in the third quadrant. Anything of the type pi plus theta is in the third quadrant, and third quadrant, who is the guest? It is tan and cot. All other are the host is tan and cot, and all the others are guests. So if they are guests, they carry a negative sign. That is what it is. So cosec also is a guest in this quadrant, and therefore it will carry a negative sign. So for all the conversion, it will carry a negative sign. It will become minus something. Now what is that something? That we will decide. Whenever we get such kind of angles, we have seen that we can drop this and we can go to the later part. So we will get this as cosec pi by 6. Again, for this host of formulae we have studied, so from there we are getting this minus cosec pi by 6. Pi by 6 is 30 for us. So cosec 30, if you know directly, otherwise sin 30 is half, and that way cosec 30 is going to be minus 2. So finally, the entire working comes to a value like minus 2. Now let's go to the LHS and see what the LHS says. Now, the LHS. What does the left hand side say? It is 2 into sin squared 30. Sin 30 is half for us. So it is half squared actually. Half into half if you want. Then next term, it is cosec squared 7 pi by 6. We got it as minus 2 because it's squared. Minus 2 into minus 2 into cos 60. Cos 60 for us it's half, and because it's a square, so half into half. Now let's see how this goes. 1, 2 can cut, both 2's can cut. So what are we left with? Half over here, and minus into minus plus. We are only left with a 1. 1 plus half, 1 and a half. 1 and a half, 3 by 2. Either you use that logic, otherwise you can take it like this. Denominator is 1 into 2 into 2. So 2 plus 1, 3 by 2. And that is our RHS. That's how we go about doing this part 2. Now similar on the same lines we have part 3. So let's see what the part 3 says. In the part 3, they ask us to show that cot squared pi by 6, they give us cot squared pi by 6 plus cosec 5 pi by 6 plus 3 tan squared pi by 6. They say is equal to 6. I hope everything is correct. Cot squared pi by 6, cosec pi by 6 plus 3 tan squared pi by 6 is 6. You've got to show this. Now again, these are standard angles. These are 30. This is 30. This is also 30. But this is not standard. So like here, we'll convert that first. And then we will see how we can work this out. Okay. So let's see how this goes. First, let's consider cosec 5 pi by 6. Again, it's always clear to us that the denominator has to come into numerator in some form or the other. So like that, when we see, you can write this as 6 pi minus pi by 6. That's the most convenient form of writing 5 pi. Like we did there, we will have cosec 6 pi by 6 minus pi by 6. So that is like writing cosec pi minus pi by 6. Moment you get something like this, our work is to classify into quadrant. Which quadrant? Now pi, this is like writing pi minus theta. And pi minus theta, which quadrant it is? It is in the second quadrant. And in the second quadrant, the host is cosec and sine. So they get positive signs, others will get negative sign. So in the conversion, you're going to get positive, and this goes off, you'll get cosec pi by 6. Cosec pi by 6, we know that it is 2. So this much value is there with us. Now let's come to the LHS. Let's go to the LHS. And what does the LHS say? It is cot squared 30. Now cot squared 30 for us, it's going to be cot 30 is going to be root 3. So it is like root 3 into root 3. Then next it is cosec 5 pi by 6. There's no square. Yeah, so only cosec 5 pi by 6. So that's 2. And 3 into tan pi by 6, tan 30. Tan 30 is going to be 1 by root 3. So it's 1 by root 3 into 1 by root 3. So these are the terms. Root 3 into root 3, we know it's 3. And this 2 will remain as it is. And this root 3 into root 3, we all know is 3. So that 3 and this 3 can cancel. We are left with 1. So 3 plus 2, 5. 5 plus 1, 6. That's how we get the RHS. The moment we get the RHS, we have proved the result. Hence proved. We have to conclude. Hence proved. So that is about our first part of the video. The remaining questions we take it up in the next part. Thank you.